Greetings, Pornandal. Here, this video is especially done for the beginners for using the FEMM tool. Now, I would just demonstrate how to do an electrostatic problem using a simple model in FEMM tool. First of all, after downloading the FEMM tool software, to go to File, click on New. Here we can just solve 4 kinds of problem: magnetic, electrostatic, heat flow and current flow problem. I've just considered an electrostatic problem, so let me just select an electrostatic problem and give OK. So this is the page that has been given for drawing the model and getting it saved for running and executing the output in FEMM software. First we have to draw the model, so we have to select the node. Suppose if the coordinates are not known, randomly we can just place the coordinates and we can just produce the structure or model or symmetry for which the electrostatic problem has to be solved. If you are given with the coordinates, then according to the coordinates we can just enter the model and get the symmetry. So let me just go on for a sample problem with x and y coordinates to be given. As you all know, FEMM software is one which will deal with 2D symmetry. So let me just solve a simple problem with a simple planar symmetry. So I will just select the problem as a planar problem. The length can be selected in centimeters, meters, or with respect to what is the x and y coordinate given, and give OK. Now, in order to enter the xy coordinate according to the problem symmetry given, you can press tab and enter the coordinates. So for the sample problem, let me just enter the coordinate. So each and every time for entering the x and y coordinates, we have to press tab and give OK. So the nodes are being fixed for the symmetry for the sample problem that has been considered. Now I have to draw the lines. So select this tool, fix from which to which point the lines has to be drawn. Just click the node, then click the next node to which the line has to be drawn. Click the node, click the next node to which the line has to be drawn. So now our line has been drawn. Now I have to fix the property of the conductor as well as the boundary for which this electrostatic problem has to be done. So for that I have to go on for clicking this label, block label, and fix. So let me just say that this symmetry is being given with the medium to be add. So for adding add to be the medium to the block, I have to go to properties. I can give the boundary property and add air, or else there is a material library available in FEMM, so that I can just drop the library materials and give an OK. So if I want to fix what is the medium for this block label, I have to right click this, press the space bar. So I'll have this block type. Because I've just added the add to be the material for this block label, it will be just appearing, and give OK. Suppose if you want to form the elements to be in a triangular mesh, I can just click this tick. If not, unclick it, and I can just decide for what mesh size the element has to be there. Okay, so now adjust it. Now because it's an electrostatic problem, I have to give a lower as well as higher potential for the segments. So for that, let me just go on for fixing once again property. I go to the conductor and add property. Now let me just go on for adding the name to the property. We just say that there are two potential, one is higher and lower potential. Just say that my lower potential is 0 conductor, and the voltage prescribed for 0 conductor is 0, so I just give us OK. Similarly, I want to add another one conductor with voltage to be higher potential, so I'll write as 1 conductor. Now I have the input to be given as voltage, and I give the voltage to be 1. So give us OK. Okay. Now I have to fix in this geometry which conductor is holding the higher potential and which conductor is holding the lower potential. So for that, let me just go on. With this line, clicking this line, go to the model, right click and press space. So in this in conductor, I have to select this to be 0 conductor. Similarly, go to the line, right click, press space bar, in conductor has to be clicked as 0 conductor. Now these two segments are supposed to have 0 potential. Next, select this segment, space bar, and give this as 1 conductor and give us OK. Select this space bar, give this as 1 conductor. And now as per the symmetry and the problem that has been considered, here the medium inside these two conductor is air, and this segment of conductor is said to possess 0 volt and this is said to possess 1 volt. Now I have just modeled it. Now I have to go on for saving this. So go on to file and save. Okay, so let me just say as sample file, sample electrostatic, okay, ES file, so save. Now as per your electrostatic problem to be solved in FEMM, what I have to do is, first I have to create small elements. I have to break down this model into small element. So I would just go on for forming the number of elements for this. So once it is saved, I have to go on for clicking this yellow color button, so that it will just create the mesh or number of elements. As I've just given my mesh size to be 0.025, it will be just happening with respect to each element of size 0.025 for this total model. If not, default triangular mesh will be just got formed. Okay, so now a mesh with 5, 4, 8, 4 nodes are being created. Now I have to run and execute it. After creating mesh, to run and execute, I have to click this. Okay, and now I have to click this. So this will give you what is the number of modes and what is the voltage level from this point to this point. See, this being 0, you can just see the potential to be 0, and this being the higher potential, and it's showing the higher potential of 1. Okay. Now, if I need to plot the field, electrostatic field, I have to just go on for this symbol for creating the plot. So let me just select the contour. Suppose if I want to plot, give an XY plot in this, I have to select the contour for which the XY plot has to be made. So I have just selected the contour to be this and this. Okay. If I just right click it, I'll select the contour, and then if I just select this, okay, I go to the line, I'll select the line first. I'll select the line. Okay. So the contour from this point to this point is one for which I have to draw the plot. Now I want to have a voltage plot, means I can just draw the voltage plot. If you want to have the flux density or intensity, accordingly I can just go on for point. The number of points in the plots can be fixed as the default, or you can just name it. Okay. If you just give us okay, I'll just get the plot. Okay, because I've just given in meters along with respect to meters to what is the magnetic field intensity it is coming. Next, I can also go on for seeing the equipotential line for this. Okay, as lines, magnetic lines, electrostatic lines I can just see, or else I can also show the density plot. I can also show the arrow mark of your field for this plot in terms of electric flux density or electric field intensity also. Okay, so if we have seen here, the pink color is one which is holding the highest one, the blue color is the lowest potential. Okay, again I can also find the contour length, the force tag by using that. Okay, what is the voltage drop? See, what is the charge, what is the voltage? Suppose if you are asked to calculate the capacitance for a particular segment, accordingly I can just get the charge and voltage, I can just proceed with it. This is for the contour what has been selected. Okay, similarly if you just go on for the contour, this, okay, I want to exit this